Hey everybody, this is Larry. This is day 30 of the 2020 December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, I have some questions there. The year is almost over. Hope you doing well. Crazy year, but yeah. Let me know what you think about today's problem, Game of Life. And I solve and explain these problems live, so it's a little bit slow. My apologies. Feel free to fast forward. And I like to go over my thought process, which is how I structure these things, and not just the answer, right, or the solution. Okay, so Game of Life. I think the name really gives it away, except for maybe minor different rules. Okay, so there are rules here. We'll probably go look at it again. And for those of you whom have done the advent of code this year, well, there were three Game of Life problems, one in multiple dimension, and there's a sparse implementation, which is kind of cool. So definitely, I've been practicing this year, unintentionally, though maybe though maybe not coincidentally, because this year John Conway did pass earlier this year. So rest in peace. And yeah, so the Game of Life. Okay, let's see. I mean, I don't think there's anything really tricky about it, though. I wish they format this to be printed out in a really more clear way. But again, these are just rules. What I do, then this is Leetcode specific, is that I just I copy the rules here because that's pretty much the critical part, right? So I don't have to go up and down, I suppose. And I think that's it. You want to solve it in place. That's okay. I mean, to the array in principle, the board is infinite. What would cause the problem to activate an emotion upon the borders of the thing? How would you address this problem? Let's see. It's just one iteration, right? The next state. Okay. Yeah, I just didn't know if they wanted me to, there are different variations of it, but the idea is just, still going to be the same. Yeah, I mean, modifying it in place is not that hard per se. It's just kind of hacks, right? I'm not going to do it. Though I could give you a hint on how I would do it. I think the focus is just kind of implementing it cleanly, and it is an implementation problem because you're given all the simulation rules, and it is a simulation problem as a result, right? Like you've just basically do what it is done, and just make sure that you implement things without worrying about different things. And here, the hack that I'm thinking about, maybe there are other ways, but the immediate hack that I think about in place is noticing that each item, each cell can only be 0 and 1. So that means that, and I guess it depends on your language as well, because if in another language you store it in bool, depending on the language as well. On top of that, because in C, bool, for example, actually not 1 bit, right? It goes through a word boundary and stuff like that. But in any case, in Python in particular, each cell uses only 1 bit, but of course it's going to be represented by an int of some sort, and so you can store the next stage in another on another higher bit, and then you can kind of revert it back, or like just update it back. So that would be the idea of solving it in place. That's one idea anyway. I'm sure there are more but that would be the easy one for me to think about. But I don't that's always a little bit weird to do in place problems, though maybe in this one actually maybe makes sense a little bit. But yeah, I think I'm just going to focus on implementing this and then updating it next. So yeah, let's do that. So next board, so let's focus on implementing this cleanly. So the number of rows as you go to, this, and can this be 0? No, okay. Just want to make sure, otherwise we would have an add an if statement here somewhere. But otherwise, if this is the case, then yeah, then we construct an m by n matrix, or rows times columns matrix. Let's start it by either 0, -1. It doesn't really matter because we intend to overwrite this anyway. So yeah, this is just standard rows times columns matrix. And then now we just go for it one by one. Yeah, and again, in this case, we would just put in a sparse matrix or something. But yeah, so for X in range of rows, for each row, for each Y, oops. Now we look at our neighbors, and you can actually do the loops backwards to count the number of live neighbors. But for this, I'm just going to keep it stupid, keep it simple, because you know, the more complicated you make things, the trickier, the more likely you're to make mistakes. And this is the way that I always do my directions. Though you can also, yeah, there's actually some really clever ways using product and stuff like that. But for now, this is just the way that I usually do it. And then, the neighbor x, the neighbor y is equal to x plus dx, y plus dy. Just to make sure that this is the 8 or the, okay, so this is actually the 8 neighbors. Maybe I write this a little bit differently. Yeah, why not? It doesn't really matter. And I do it this way. You can actually write 2 for loops. Maybe that's actually slightly cleaner. So let's do that. So for dx in 1 or -1, 0, 1. For dy in -1, 0, 1. And if dx is equal to 0 and dy is equal to 0, if this is not the case, of course, and you could De Morgan this, it's fine. So yeah, so then this is the case, and then now maybe we have to check our bounds. Yeah. I don't know if there are constraints such that about the border. Okay, I guess you just ignore it. Okay, fine. Wasn't sure because sometimes some rule set will say that you assume the border is alive, or some assumes that they're dead. Seems like in this case you just assume it's dead. So yeah, so then here I forgot to do something, which is that we keep track of count, and then now we go if we make sure that nx is within rows and y is equal or within columns, and we even put here, which is and board of nx and y is equal to 1. Then we add a count, right, for being alive, and then now we just go through this this thing, which is that okay. Let me read this a little bit. Okay, so it is a dead cell. So then we could do something like if board of xy is equal to 0 and neighbor is equal to the number of neighbors is equal to 3, or what is the other one? Board of xy is equal to 1 and let's see, 2 or 3 goes on to the next generation. So basically only 2 and 3 lives, so n count is that's between 2 and 3. If this is the case, then next board of xy is equal to 1, else just set it to 0. I know that it is default already 0, but I just want to make it explicit. Yeah, and that's pretty much it. And now we just have to transfer it back. Again, you could do some hacks on the higher order or higher or just like any other significant bits, and then change it back in another pass. But in that case, you have to go for another pass anyway. So I don't know, same thing, I suppose. So that, and if it's gonna be the same thing, I might as well as keep it clean. Maybe there's a slicker way. If there's a slicker way, we'll learn about it together. Whoops, did away. Yeah, I think that's mostly it, unless I have some weird error. Yeah, let's also do the other one, I suppose. Cool, looks okay. Let's give it a submit. Hopefully it is good. Yay. So what is the complexity of this algorithm and space? We do As we said, because we keep it clean, we do use another additional rows times column space, and of course these loops will make it there's rows times column number of loops, and each of them do 9 operations, give a 9 constant 9 sets of operations maybe. So it's going to be row times columns in time and space. And of course, because rows times columns is actually the size of our input, this is going to be linear in the size of the input and linear in the in time and space is what I meant to say. Definitely maybe this is a good shout out to Professor Conway, and may he rest in peace. Let me know what you think about this poem. I think it's pretty okay. Yeah, I mean, any self-respecting computer scientist has probably implemented the game of life once. So definitely play around with that, see if you explore it. Let me take a quick look at the solution, just in case maybe this. I'm curious about the in-place one that isn't like quote unquote clever about the bit. Yeah, okay. I thought there'll be, yeah, because you have to update them at the same time. So maybe, wow, so. Let's see. Well, in this case, they did not do it in place, right? Oh, there's an one extra space solution. Let's see. Oh yeah, okay. So I mean, this is essentially what I was saying with the significant bit, and then just apply it again. I mean, you could call them different flags or something. It doesn't really, but like, same idea, right? Which is just use the fact that it is not a true boolean to do it that way. And again, in infinite board, as we said, we can use a sparse version of this by holding it in set or something like that. There are a lot of different ways to do it, or a counter, I suppose. And maybe this is also a good shout out for admin of code if you haven't done it, because they basically there were 3 problems this set that dealt with game of life, but yeah. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord, and I will see y'all later. Bye bye.